Moving on, we are now in section 6.5, operations with radicals and roots. This section is pretty much simplifying. It's not super hard, but just showing you lots of different ways you can rewrite them. So, start right here with the cubic root of 27y to the 12th, z to the 7th. So, I'm going to rewrite this 3 to the 3rd, because 3 times 3 times 3 is 27. 3 to the 3rd, y to the 12th, then z to the 7th. And I got to take the cubic root of this. Now actually, I'm going to rewrite this again. I'm going to write this 3 to the 3rd, y to the 12th, z to the 6th, times z. I did this for a specific reason that I'll show you here in just a moment. When I take the cubic root of all of these, what raised to the third power gives me 27? That would just be 3. Third root of 3 to the third is just 3. Y to the 4th gives me is a cubic root of y to the 12th, because this is y to the 4th times y to the 4th times y to the 4th. Z to the 6th breaks down to z squared, and z squared. So that's z squared right there. But you'll notice I've got an extra z hanging on here. I can't take the cubic root of that. So I'm just going to write the cubic root of z. Just like that. So that's how I tend to do mine. Break it up into 2 parts, and then take the cubic root of the parts individually. Over here, the first thing I'm going to do is I'm actually going to go ahead and multiply the numbers on the outside. That's going to give me 6. And if I have the 4th root, since both of these are to the 4th root, I can actually go ahead and multiply them together. 8 times 2, of course, is 16. X to the 3rd times x to the 5th gives me x to the 8th. And y squared is going to give me y to the 4th. Now, got to take the 4th root of this. Well, let's rewrite 16. 2 times 2 times 2 times 2. Hey, that's 2 to the 4th. So we have the 6th root of 2 to the 4th, x to the 8th, y to the 4th. Now, what's the 4th root of 2 to the 4th? That's just going to be 2. What is the 4th root of x to the 8th? Well, that's x squared times x squared times x squared times x squared. So that's got 4 of those. So it's x squared. What's the 4th root of y to the 4th? It's just y. But we do remember from last time, if I've got an even root of something and the result is an odd exponent, we can't have y be negative, because square roots or 4th roots or 6th roots only give us positive answers, so we got to put an absolute value around this. And then we still got the 6 on the outside here. And we're going to take 6 times 2, which gives me 12, x squared, absolute value of y. Final answer there. The next one right over here. I got to multiply 6 times the square root of 3 minus 5 times the quantity 2 times the square root of 5 plus 4 times the square root of 3. To do this, FOIL it, distribute just like normal. You probably saw this coming. It's not hard. 6 times 2 is 12. Square root of 3 times the square root of 5 is the square root of 15. 6 times 4 is 24. Square root of 3 times the square root of 3, of course, it'd be the square root of 9, which is 3. We know it's a square root of 9, but I'm just going to write it as 3. Negative 5 times 2 times the square root of 5. And we'll get negative 10 times the square root of 5. Then negative 5 times 4 times the square root of 3. Negative 5 times 4 is going to be negative 20 times the square root of 3. And let's see if I can combine any of these. Well, I can multiply that, give me 72. This is 12 square root of 15. Can't break that down at all. This is 10 times the square root of 5. Can't break down 5. 20 square root of 3. And can't break that down. This breaks down to 3 and 5, but no squares to simplify there. As long and as ugly as it is, that is my answer. Alright, so that's how you multiply and simplify using radicals and nth roots. Now we're going to find out what happens when you have to divide. Division is always a little bit more difficult. We'll see that in the next section here. Division with square roots and nth roots. A little bit more complicated. We're going to start with an easy one right here. We know we can take this. We know we can split up this into the square root of 4 over the square root of 9. Square root of 4, of course, would be 2. Square root of 9, of course, would be 3. No problems there. This next one, it's square root of 4/3. Now we have to split this up because we can't have in theory, we can't have a square root in the denominator. It's bad math grammar. Now when you get to later sections of math, it doesn't matter so much. But right now we're still just learning, so we're going to split this up. Square root of 4 over the square root of 3. Now what's the square root of 4? That's just going to be 2 divided by the square root of 3. Uh-oh, we can't have a square root in the denominator. So how am I going to get rid of this? Well, I'm going to multiply top and bottom. In order to get rid of this, I need to get rid of the square root somehow. So I'm going to multiply it by the square root of 3. Why would I do that? Well, because on bottom then, that's going to give me the square root of 9. On top, it's going to give me this 2 times the square root of 3. But I can take the square root of 9. That's easy. So it's going to be 2 times the square root of 3 all over 3. So to get rid of it, I just multiplied this by whatever I needed to in order to get rid of the square root. Same thing on this next one here. A to the 9th, b to the 5th, I'm taking the square root of that whole thing. Let's split it up. Square root of a to the 9th over the square root of b to the 5th. Alright, a couple different ways we can do this. Let's just start by simplifying what we can here. A to the 9th, well, I can rewrite this as a to the 8th times a. Because the square root of a to the 8th is just going to be a to the 4th. Square root of a, that nothing I can pull out there, it's just going to remain square root of a. B to the 5th, I can rewrite this as square root of b to the 4th times the square root of b, because that gives me b to the 5th. Square root of b to the 4th would be b squared. Square root of b. Well, we got a square root on the bottom right here. How am I going to get rid of this? Multiply top and bottom by square root of b over the square root of b right there. Square root of b times square root of b is going to be b. No pun intended. And I'm going to have a to the 4th times the square root of ab. Now, since this one is an absolute value, is just b to the 1st, but it's an even root, we have to put absolute values around this. And that, actually what I'm going to do is I'm going to put absolute values around the whole thing. Just got to make sure the bottom is positive. It's got a to the 4th times the square root of ab. The next one right here. Last problem. The cubic root of 3a to the 6th over 4y. Once again, going to split this up. Square root of 3 times the square root of a to the 6th. Sorry, cubic root Then what's the cubic root of 4 and the cubic root of y? Now here's where we have to think a little bit. Can I take the cubic root of 4? I can't. 4 breaks down to 2 times 2, but there's nothing cubed there. So I'm going to have to multiply top and bottom by something to make sure I can take the cubic root of this. So what am I going to multiply by? I'm going to multiply top and bottom by cubic root of 2. Because that will give me the cubic root of 8 on bottom, which I can take the cube root of and get 2. Now I've got the cubic root of y down here. How many more y's do I need to get rid of this? 2 of them. Because now the bottom down here is going to be the cubic root of 8. 4 times 2 is 8. And the cubic root of y times y squared is y to the third. Now you got to do the same thing on top, of course. So I'm going to get the cubic root of 2 times the cubic root of 3 is going to give me the cube root of 6. Can't simplify that at all. 3 and get the cube root of a to the 6th and the cube root of y squared. I'm not going to simplify these because I was trying to simplify the bottom. What's the cube root of 8? 2. Cube root of y cubed? Y. I can simplify this. The cubic root of a to the 6th. We know a to the 6th is just a squared times a squared times a squared. So there's 3 of them there. That's the cube. So that's going to give me a squared. But I can't simplify 6. I can't simplify that. So I'm going to get the cube root of 6y squared. Once again, these are just going to take a lot of practice, doing them over and over again. Big lesson here is you can't have a cubic root on the bottom or a square root on the bottom. You're going to need to multiply by however many extra factors you need to get rid of it. So down here there were 5. I needed an extra one, so it was b to the 6th. That way I could get rid of that square root. Over here was square root of 3. I need an extra square root of 3 so that the square root would go away and become square root of 9. Over here I had 4, which is 2 times 2. I need an extra cubic root of 2 in order to get rid of that. I need 2 extra y's to get rid of that one. So multiply the denominator by whatever you need to, in order to get rid of the roots on bottom. Thanks for watching. Last example. Once again, we cannot have a square root on the bottom. That is a mathematical no-no. At least for now, anyway. So, how do we get rid of this? Well, you remember when we had, if I gave you the problem 3 over I minus 4, we had to multiply by the conjugate of this, which would be I plus 4 on top and bottom. And when I did that, it gave me I times I would be I squared. I times 4 would be plus 4i. That would give me negative 4i, so those canceled, and then we get minus 16. Of course, I squared is negative 1. Minus 16, which gives us negative 17 on the bottom. And then just distributing this on top gives me 3i plus 12. So, sorry about that. So, multiply the bottom by the conjugate here, and then that gave me I squared plus 4i minus 16. Then negative 1 minus 16. And then distribute the top, just like that. We're going to do the same thing over here with this problem. We're going to multiply by the conjugate of the bottom. So the conjugate of the bottom here is going to be the square root of 6 plus 4. Alright, so going to do the same thing here. Distribute the top. 3 times the square root of 6 plus 3 times 4 is 12. On the bottom here, square root of 6 times the square root of 6 is the square root of 36, which is just, of course, 6. Square root of 6 times 4 is plus 4 square root of 6. Multiply those, minus 4 times the square root of 6. Oh, those cancel out. It's difference of squares, that's all it is. Then negative 4 times 4 is negative 16. So simplify the bottom now. 6 minus 16 is negative 10. So I'm going to get 3 times the square root of 6 plus 12 all over negative 10. So if you get a square root on the bottom here, just multiply by the conjugate. If it's square root of 6 minus 4, got to multiply by the square root of 6 plus 4. And that's how you get rid of the square roots on the bottom.